Okay, so projectile motion. Now this is a projectile given an angular projection. Now consider an object which is thrown with some velocity u. Now this is the velocity making an angle theta with the horizontal. Now this is the initial velocity making an angle theta with the horizontal. The body covers this path. So this is actually the projectile motion. Now we can actually resolve the velocity u into its two components, that is the horizontal component, this will be u cos theta, the horizontal component, and the vertical component, since this is making an angle theta with the horizontal. Now this is the vertical component, so this will be u sin theta. Now see, these two vertical components, u cos theta and u sin theta, they are independent of each other. Now see, in u cos theta, this is actually the horizontal velocity. Now see, there is no such force acting on it. So the acceleration ax in the horizontal direction is 0, whereas in u sin theta, it undergoes an acceleration which is the acceleration due to the gravity g. So its value keeps on changing. If we consider h as the highest point, okay, h is the highest point, and draw this line. This is ah. This is actually the maximum height reached. So see, because of its two component velocity u cos theta and u sin theta, it covers a horizontal distance as well as the height. Now see, u cos theta is going to be same throughout the motion. So throughout this motion, the u cos theta will same, but u sin theta will vary because of the acceleration due to gravity g. So it is maximum at the point of projection and keeps on decreasing till it reaches 0 at the highest point, and from h, as it goes down, it keeps on increasing and reaches the highest value just before hitting the ground. So at the highest point, this will be just u cos theta, as u sin theta is 0 at this point. Now we can also consider a point P on this line. Let its coordinates be x comma y. Coordinates be x comma y. Now it's obvious that this line is y and this distance is x. Okay. So first of all, we will be like taking the we will be getting the equation of trajectory or equation of its path. Okay. So starting with this only, like suppose at any time t, the object reaches the point P. This is x comma y. Now considering x as the horizontal distance traveled by the object in time interval t. So x is basically the horizontal distance. If you take x is the x, that is equals to horizontal distance. This is the horizontal distance traveled in time t, and y is basically the vertical distance traveled in any time interval t. Okay. So first of all, we will take motion along the horizontal direction. Now motion along horizontal direction, along horizontal direction, that is along this OX. Now see, since the velocity of object in the horizontal direction is constant, so basically I mean to say that there is no force acting in the horizontal direction, so hence velocity u cos theta, that remains constant. So the position of the object at any time t along the horizontal direction, so x, if we take x as the distance of the horizontal distance, so basically it is just a u cos theta throughout the motion and in time t. So applying the formula, see, horizontal distance is speed into time. What is the speed? Is u cos theta into t. That is the horizontal distance. This is equation 1. So we can find the time t also from this equation. T is equals to x by x upon u cos theta. So this is t. Now taking the motion along, so this is the motion along the horizontal direction in which u cos theta is constant, so just distance is speed into time, speed is u cos theta into t. Now motion along the vertical line, along vertical direction. Now the motion along the vertical direction. Now in this case, in a vertical direction, there is g acting on it. Now, so the position of time, g is acting vertically downward, we are considering it going to be upward. So basically the direction of g taking downward direction, but I mean to say is that taking the downward direction as positive. So g will be negative for this object, for this motion, because this is initially in the upward direction. So applying the second law of equation, s is equals to ut plus half at square. So this, in this case, this will be y equals, see what is the initial velocity, u sin theta into t. So this is ut, u sin theta into t, and this will be minus half g t square. Minus is why, because the acceleration due to gravity is negative. So by the second equation of motion, ut, initial velocity is u sin theta, as we have discussed, this u sin theta into t minus half gt square. Now we can substitute the value of t from this one, from this one. T is this, t is x upon u cos theta. You can consider this as equation 1. So, t is x upon u cos theta. Now substituting the value, so y equals, this is u sin theta into x by u cos theta minus half g, this is x square by u square cos square theta. Okay. Now solving this, you will get cancelled. So this will be x tan theta, and this will be 1 by 2 g u square cos square theta into x square. So rearranging it, this y will be equals to x tan theta minus, this is 1 by 2, this is g upon u square cos square theta in bracket, and this is x square. So this is what the equation of trajectory. Now look at this. This is an equation of basically a parabola, and the path of projectile projected at some angle with the horizontal direction from the ground is a parabolic path. So time of flight. Now it is the total time for which the object is in flight. So object in flight means like when it is from O to B. Now this is the total time of flight, and we can denote this time of flight by capital T. We are denoting it by capital T. Now again to this. Now see, if we take small t, let t be the time interval, and we take this as time of ascent, means time taken to reach from point O to the highest point, and time of descent as like time taken from reach the highest point to point B, the lowest point. So basically time of ascent equal to time of descent. That means if t is the time taken to reach from minimum to highest level, then t will, at the same time, that like time t only will be required to reach from highest level to the lowest point. So basically if this t, we take small t, so basically this t is equals t plus t, that is equals to 2t. So this small t is what? This small t is the time of ascent, the time of descent, which is the same. So hence we will find small t, and then what we will do? We will do twice of this to get the time of flight. Okay. So starting with the equation, we know that v equals u plus at. Now we know that since this is the motion in the upward direction, okay, so this is the motion in the upward direction, and at the highest point it reaches 0. At the highest point the velocity becomes 0. So taking this as 0 equals, now what was the initial velocity? It was u sin theta. The initial velocity was u sin theta. So now see, this is u sin theta, again a will be minus g into t. Okay, so you can write this as u sin theta equals gt. So this implies t is what? T is u sin theta by g. U sin theta by g. Now what is the time of flight? Time of flight is 2t. So time of flight capital T, this will be 2u sin theta by g. So this is our time of flight. Now the maximum height. Now it is the maximum vertical height attained by the object above the point of projection during its flight. It is denoted by h, small h or capital H, whatever you can denote. So basically this is the maximum height. So now how to get an expression for the maximum height? Okay, we start with the second equation of motion, so which is S is equals ut plus half a t square. Now this is S is ut plus half a t square. Now applying this, S we can take this as height. We know that initial velocity is u sin theta. This is the initial vertical velocity. So this is u sin theta into t. We know that a is minus g. We can directly write this as half g t square. Okay. Now we also know what is t. T is the time taken to reach the maximum height, which was t is u sin theta by g. So substituting this equation in this t. Now see, now h is equals, this is u sin theta. Now see, t is what? Is u sin theta by g minus half g. This is u square sin square theta by g square, because this is t square. Okay, now this will be u square sin square theta by g. So this will be u square sin square theta by g. Okay, and this will be minus half. See, this g and this g will get cancelled. So this will be u square sin square theta by g. You can take LCM, or directly this will be half of it, because this is 1 of u square sin square theta by g, and this is half of u square sin square theta by g. So what you can take is that you can take u square sin square theta by g common. So this will be 1 minus 1 by 2, so basically half. So this is actually, so this is equals to 1 by 2, which is u square sin square theta by g. So expression of capital height, the maximum height for the capital H will be u square sin square theta by 2g. So this is the maximum height reached. Horizontal range. Now it is the horizontal distance covered by the object between its point of projection and the point of hitting the ground. It is denoted by r. So basically if we talk about this, so horizontal range is from point O to point P. So this is the horizontal range. Now see, horizontal range is basically the horizontal distance. Okay, the horizontal range is the horizontal distance covered by the object, and we know that throughout his motion u cos theta is constant, and to find the horizontal range, what we will do is that speed into time. Now what is the time? Time is the time of flight. The time of flight, which we have already calculated, time of flight t, this is equal to 2u sin theta by g. You should remember this, 2u sin theta by g. So applying this over here, horizontal range. So basically r, capital R, this is denoted as capital R, which is equals to u cos theta times t. Okay, now substituting the value, this is u cos theta. What is t now? T is 2 u sin theta by g. So this will be, this is u square into 2 sin theta cos theta by g. Now 2 sin theta cos theta is, in trigonometry, is u square sin 2 theta by g. So this is the expression for the horizontal range. So r is u square sin 2 theta by g. So this is an expression for the horizontal range. Maximum horizontal range. Now see, for the maximum horizontal range, if you look at the expression of horizontal range r is equals to u square sin 2 theta by g. Now see, we note that, as you can see from speed u of the object, the value of horizontal range that depends upon the angle of projection theta. That depends upon the angle of projection theta, as you can see g is constant at a place. Therefore, the horizontal range r will be maximum when what? When sin 2 theta, when this sin 2 theta, this becomes maximum. So when sin 2 theta becomes maximum. Now when sin theta is maximum is what? At 1. That means, and sin 90 is actually 1. So basically this 2 theta, so this 2 theta will become 90 degree. So theta is actually 45 degree. So this is the angle of projection to get the maximum horizontal range. So R max is what? Is u square by g, because sin 2 theta, because sin 2 into 45, I just write it, sin 2 into 45, this is 90 degree, which is equals to u square by g. So hence, to achieve the maximum horizontal range, the object should be projected at an angle of 45 degree with the horizontal direction. And this concept has been actually used by the athletes. You know, the athletes, they use in long jumps, javelin throw, and also the cricket ball throw. Now the two angle of projection for the same horizontal range, two angle of projection. We know that when the object is projected with the velocity u making an angle theta with the horizontal direction, the horizontal range is given as r is u square sin 2 theta by g. Now this is the horizontal range. Okay. Now when the object is projected with the velocity u, now it is projected with the velocity u, now the angle is 90 minus theta. Now see this point, the angle is 90 minus theta with the horizontal direction. Then what will be the horizontal range? You consider this as r1 and this as r2. So this r2 will be u square sin 2, this will be 90 minus theta by g. Solve this, this will be u square sin, this is 180 minus 2 theta by g, and we know that 180 minus 2 theta will be 2 theta only. So basically r2 is u square sin 2 theta by g. So see, what we get is r1 equals r2. Now thus the horizontal range is same whether the angle of projection is theta or 90 minus theta with the horizontal direction. So even if you suppose you throw a ball or a ball, you can take a ball or a stone with an angle of 15 degree and 75 degree, that will be same. 90 minus 75 is 15. Similarly, if you throw it at an angle of 30 degree and 60 degree, that will be the same, means they will give you the same horizontal range. So two tall buildings are 200 meter apart. Now see, there are 200 meter apart. With what speed now must the ball be thrown horizontally from the window of 540 meter above the ground in one building so that it will enter, so it's 540 meter above the ground in one building so that it will enters a window 50 meter above the ground in the other. Now see, for the diagram you can look at this. Now see, here A and B, that represents two different buildings. A and B, that represents two different buildings which are, now this distance is 200 meter apart, 200 meter, that is given to you, they are 200 meter apart. W1 and W2 are the two windows A and B respectively. This is window 1, this is window 2. Now see, the height of window 1 is basically, this is what, 540 meter from the ground, and the height of window 2, this is 50 meter from the ground. This is 50 meter from the ground. Okay. Now ball is thrown horizontally. So basically this is the initial velocity of the ball, and initial velocity is given to it, but the vertical velocity is downward vertical velocity is 0. So it goes like this and it enters the second window. Okay. Now we know that what is W1? Now we know that, now see, height of W1 was 540 meter. W1 is 540 meter and W2 is 50 meter. So basically the net vertical height that this ball will travel, net vertical height is actually 540 minus 50. So this is actually 490 meter. So taking this as the vertical, like vertical distance that it has to travel, 490 meter in this. Now again using the third equation, sorry, the second equation of motion, S is ut plus half at square. Now see, you can use the vertical motion, y, this is equals to, now what was u y t? Actually this was 0 plus half of g t square, because it is going downward and we have taken the downward velocity as positive, so taking g as positive. So this is what, 490. This is 0 because initial downward velocity is 0. So this is 0 plus half into 9.8 into t square. So this is what, this is 4.9 t square. Okay. Now 490 equals this. So 490 upon 4.9 equals t square. So this is equals what, 100. So what is t? This implies t is what? T is 10 seconds. So basically the ball is taking 10 seconds to reach from W1 to W2, means the vertical distance. Now 10 seconds. So according to the question, so it will enter. With what speed must the ball be thrown horizontally? So we have to find the horizontal velocity. Now see, now taking the motion of the ball from W1 to W2 along this. Now again, if we are taking the motion of the ball, now see, from W1 to W2, the motion of the ball. Okay. So the horizontal motion, again the second equation of motion, so x is equals uxt plus half a by t square. Now we know that this is 0 because there is no sorry, so not ay, this is ax. We know that ax is 0 because its horizontal component has no effect of velocity, no effect of acceleration due to gravity. So x, we know x is how much, 200, and ux we have to find, we know that time is how much, 10 seconds, plus this actually becomes 0 because we have discussed this, ax is 0, this is actually ax t square. So that ax is 0 because the acceleration in the horizontal direction is 0. So what is ux? The horizontal velocity with which it is projected is 200 by 10, that is 20 meter per second. So this is the horizontal velocity. Next question. A plane flying horizontally at 100 meter per second at a height of 1000 meter. Now the speed is 100 meter per second at a height of 1000 meter, releases a bomb from it. Okay. Find the time it takes to reach the ground. Find the time taken by the bomb to reach the ground and the velocity with which the bomb hits the targets on the ground, and see the distance of the target. Now the distance of the target means the horizontal range. So see, this is an diagram. Now see, you consider OI as the vertical height, which is actually 1000 meter of this plane, and this is moving at a speed of 100 meter per second. So this will be the actual motion. So 100 meter per second, it drops a bomb from here. The bomb will do that projectile motion and it reaches here. So we have to find the velocity. Now at this point I have taken Vx and Vy because we have to find this velocity. Now this velocity will have two perpendicular components or rectangular components, Vx, Vy, the two rectangular components. Okay. So let's start our question. So the bomb be released from the aeroplane O. This is O, which is the origin of the coordinate axis. Now we know that OX, OY and so on. Okay, now the first question is find the time it takes to reach the ground. So basically if we are taking the vertical drop, since see the plane was having its horizontal velocity, there is no such vertical velocity. So taking the motion of the bomb from O along the vertical drop, okay, again applying the second equation of motion, S is ut plus half at square. So this y will be equals to uyt plus half ay, sorry, this is ay t square. Ay is basically, this is g actually, okay. So we know that this is how much, this is 1000 meter, which is uyt. Uyt is actually 0. There is no such vertical velocity provided, as I have told you that the aeroplane was moving with horizontal velocity. This is 1000 meter, y is 1000 meter plus this is half, g is actually 9.8, the 9.8 t square. This half of 9 is actually 4.9 t square. So 1000 equals 4.9 t square. So 1000 by 4.9, this is equals t square. You can write 1000 by 4.9 as 1 0 0 0 and one more 0, releasing this 49 equals t square. Okay. So this t is equals under root of 10,000 by 49, which is, this is 100, actually 100 by 7 seconds, or if you solve it, this comes out to be 14.28 seconds. So this is the time it takes to reach the ground, the time taken by the bomb to reach the ground. Now the second question was that, the second part was that the velocity with which the bomb hits the target in the ground. So see again, now we are talking about this velocity. So we have to find both Vx and Vy. So finding Vy first, the vertical motion. Now see Vy using the first equation of motion, since the initial vertical velocity is 0. So this is 0 plus 9.8 into how much time it has taken? 100 by 7 seconds to reach the ground. So 100 by 7, you solve it. So this will give you 140 meter per second. So Vy is 140 meter per second. Now what is Vx? Now we know that throughout this motion, the horizontal velocity will remain same because there is no force or the acceleration acting on it. So Vx will be 100 meter per second, 100 meter per second. Now this v, considering this v as the horizontal velocity. Now this v is the horizontal velocity, these are two rectangular components. So v is equals under root of, this is Vx square plus Vy square. So this is actually equals to Vx square is 100 square plus this is 140 square. Okay. Now you solve this 100 square plus 140 square. So this v is yeah, so this v is 172.1 meter per second. So is this v with which it hits the ground. Now the thing is that the velocity is a vector quantity, so we should know its direction on also. So that's why we have to find this angle beta. that it makes with the horizontal direction. So, we know that tan beta will be Vy by Vx. So, tan beta, to find this, tan beta will be Vy by Vx, that is Vy is how much, was 140 by 100, this is 1.4. So, this beta is 54 degree 28 minutes. Now, third part, the distance of the target. Now, this is an easy part. Now, distance of the target means you have to find this horizontal distance. So, what was the horizontal speed? It's 100 meter per second. Time taken was 100 by 7. 100 by 7. So, its distance of the target is basically the horizontal distance. The horizontal distance axis, this is 100 into 100 by 7, which comes out to be 1428.5 meter. That is the distance of the target, means this distance. The question is, the fighter plane flying horizontally at an altitude of 1.5 kilometer. Now, 1.5 kilometer, we have to, I think later we have to convert it to meter, with a speed of 720 kilometer per hour, passes directly overhead an anti-craft gun. Now, at what angle from the vertical should the gun be fixed for the shell with muzzle speed of 400 meter per second to hit the plane? So, basically plane is directly overhead the anti-aircraft gun. So, see, this is the diagram. Now, see, this is an anti-aircraft gun. So, this was the plane. You can take its velocity u as 720 kilometer per hour. Okay, flying that like this. Now, this is the velocity of that anti-aircraft gun. So, now this makes an angle theta with the vertical. Now, the question is, at what angle from the vertical? See, vertical, so this is theta with the vertical. So, to find the vertical. Now, first of all, we have to resolve the velocity u. So, actually, since this is theta, so this will be u cos theta and this will be u sin theta. Now, see, okay, so this is a diagram. Now, see, the fighter plane is flying at a horizontal speed u dash with a height of 1.5 kilometer. That is fine, this is 1.5 kilometer. At point O represent the position. Now, this is the point, you can consider this as point O, represent the position of an anti-aircraft gun. Let the shell be fired with the velocity, this is u, making an angle theta with the vertical directions, so that it hits the fighter plane. Now, we have also resolved it into vertical component. Now, what is the theory behind this is that u cos theta, yeah, you see u cos theta is vertically upward, u sin theta horizontally. Now, what is the theory behind is that if t is the time taken by the shell to hit the fighter plane, okay, now t, the time taken by the shell to hit the fighter plane, then the horizontal distance traveled by the fighter plane in time t with velocity 720 km per hour is equals to the horizontal distance traveled by the shell in time t with velocity u sin theta. So, first of all, let us do our conversions. So, conversion is the horizontal velocity of plane is actually 720 kilometer per hour. So, if you convert this to meter per second, you know how to convert it. So, this is actually 200 meter per second. So, this is the horizontal velocity of the plane, which is actually equals to 200 meter per second. Now, the horizontal distance traveled by the plane, we are taking time t when it is hitting the plane. So, let t be the time taken. So, the horizontal distance covered by plane is how much? This is 200 t, speed into time. Now, see, the horizontal velocity of the bullet is u sin theta. So, same, the horizontal distance covered by the bullet is what? Is u sin theta into t. Now, these two should be same. this one and this one, so that it hits the plane. So we write 200 T equals U. Yeah, U is actually for bullet is given in the question is 400 meter per second. So we can substitute over here. This is 400 sin theta into T. Okay. So T and T will get cancelled, and this is 200 divided by 400, that is equals to sin theta, which is basically 1 by 2, or this implies theta is 30 degree, because sin 1 by 2 is 30 degree. So 30 degree angle with the vertical, that means this angle should be 30 degree. A hunter aims his gun and fires a bullet directly at a monkey in a tree. At the instant the bullet leaves the barrel of the gun, the monkey drops. Will the bullet hit the monkey? Now we have to explain this. So will the bullet hit the monkey? Now consider this diagram. Now let the monkey be stationed at point A. So this is the point where the monkey is stationed, and the gun be are fired with the gun. Now this is the position of the gun O with the velocity U. Now this is the velocity U, and this is making an angle theta with the horizontal. Now see, now this is the diagram. Now let the bullet cross the vertical line AC. Now this is the vertical line. So basically the path of the bullet will be like this. So it is going to hit at B. Okay. Now consider the coordinates of B as x comma y. We know that this is what? This is x and this thing is y. The coordinates of B is x comma y and this is u. Okay. Now resolving the components, this will be u cos theta and this will be u sin theta. Now see, to cover this distance, actually we will take the horizontal motion. So we know that in the horizontal motion that this remains the same. So let the bullet hit this point. Now this is the vertical line AC, which is directly when the monkey will fall. So I have drawn this line. So let this bullet hit at any time interval t. So what is this OC? OC is basically x. So this OC is actually u cos theta, means OC is actually the distance is u cos theta into t, distance is speed into time. Okay. So what is t? T is, that is OC by u cos theta. Now we know that OC is what? OC is x. So this is x by u cos theta. So this is our time. Okay. Now now see, now in triangle OAC. Now what is AC? AC can be written as OC. AC can be written as OC tan theta. So OC is what? X. So in this triangle